Good morning, everyone. We are Group 5 presenting our project on big data analytics on Airbnb listings and reviews using the Hadoop ecosystem. Next slide. Starting off with our problem statement, massive Airbnb data makes it very challenging to extract meaningful insights using conventional tools, and so a scalable big data framework is needed to support smarter data driven decisions. Moving on to our project objectives, this project aims to efficiently store and process large Airbnb datasets, extract insights on prices, ratings, hosts, and reviews, predict future trends using machine learning, visualizing findings through interactive dashboards, and evaluating the effectiveness of Hadoop ecosystem tools. Next slide. Here we have our overall system architecture. I'll briefly walk you through it as we'll be going much into depth in the upcoming slides. At a high level, we have the raw Airbnb data flowing through the HDFS for storage. It gets cleaned through Apache Pig and then it branches into Hive for SQL analytics, MongoDB for review analytics, and Spark for machine learning, with everything finally visualized in Power BI. Next slide. So starting with our first task, we implemented Hadoop in HDFS to provide a scalable and fault-tolerant storage environment for the Airbnb datasets. The listing datasets, which is 7.2 MB, and the reviews dataset, which is 10.3 MB, were stored and managed using HDFS commands. This distributed storage architecture then served as a foundation for all of the subsequent analytics and machine learning tasks. The supporting tools such as Apache Pig, Hive, MongoDB, Spark, and Power BI were used across the Hadoop ecosystem. Next slide. Next, we have the data cleaning stage. Here we use Apache Pig on Cloudera to run the ETL stage, following a simple load, filter, group for each store flow. We applied 5 cleaning rules, dropping null or zero prices, removing duplicate listings, standardizing currency to Singapore dollars, and keeping only valid room types, preserving missing ratings as null. 3 transformations would then enrich the data: a numeric price column, past review dates, and host categorization. The result that we got was 71.6% of the listings were retained, all 38,350 reviews were kept, and all of this was just done in 2 minutes and 12 seconds. Notably, almost half of the hosts are inactive, so this clean output now fed into Hive, MongoDB, and Spark. Next slide. And finally, we had the Hive data warehouse, which was sitting right between the Pig and Power BI in our data pipeline. The Pig cleaned the data, Hive handled the SQL analysis, and the results then went to Power BI for visualization. We built external tables on HDFS and ran 6 queries. The chart on the left shows the central region is by far the most expensive at $376 a night. On the right, we have the superhost comparison telling an interesting story. The superhosts actually charge less, but they earn much higher ratings and 3 times more reviews. So the badge really comes from quality, not pricing. One thing worth noting about Hive is that it's very SQL friendly, meaning that anybody with database experience can pick it up quickly. The downside is that each query took 30 to 50 seconds because it runs on MapReduce. And in a production environment, you have to switch to Tez or Spark for faster performance. I pass on to the next presenter. Next slide.
Moving on to the next task, which is task 6, we utilize PySpark's mlib to build an end-to-end predictive pipeline. We processed 2,643 listings over 38,000 reviews from HDFS, performing future engineering and executing 4 predictive models in just 220 seconds. As shown on the slide, random forest was our standard algorithm. It consistently beat the baseline, achieving a stellar ROC of 0.9663 for listing popularity and a R of 0.254 for price prediction, and a low RMSE of 0.4805 for customer rating. We also forecasted a 6-month booking trend using sliding window regression. Ultimately, all 14 CSV outputs and 6 trained models were saved back to HDFS, perfectly primed for our downstream Power BI dashboard. Next slide.
For the review analytics phase, we deployed a MongoDB 8.0 architecture via Docker. A major technical highlight here is achieving 100% data verification pass rate, successfully reconciling over 38,000 documents spanning over 18 years. To guarantee high concurrency retrieval, we meticulously designed 4 core indexes, most notably a crucial geotemporal composite index. Leveraging the aggregation pipeline, we successfully transformed raw data into core business intelligence. We then discovered that over 95% of our users are one-time reviewers. This quantitatively proves that high transient tourist-driven nature of the Singapore market. Furthermore, our time series analysis pinpointed that December 2024 as the absolute historical peak of the seasonal market demand. Next, I pass over to next person.
Next slide. So next, for the visualization with Power BI, we turn the team's clean data from Hive, MongoDB, and Spark into 6 Power BI dashboard, all in one consistent Airbnb theme. Since our data is Singapore only, we compare by region instead of city. A few key findings. The central region has the most listing and the highest price, around $376. Listing are split almost evenly between whole homes and private rooms. The most interesting one is that the super host paradox, where superhosts are only about 15% of hosts, but they get 3 times more review and higher ratings while while charging less. And reviews follow a clear seasonal pattern, peaking in January. Once popularity model worked well at 87% accuracy, though price was hard to predict. Next slide. Next. Okay, this benchmarking analysis compared the performance of all technology used in our project. MongoDB achieved the fastest analytical processing speed. Hive provided effective SQL-based analytics. Quick handled data cleaning and transformation, while Spark MLeap delivered the strongest predictive performance. Across all machine learning tasks, random forests consistently outperformed the baseline models. Next slide. In conclusion, the project successfully achieved all research objectives. We analyzed Airbnb pricing and customer review trends, developed predictive models, and built a complete big data pipeline using Hadoop ecosystem technology. The result shows that combining multiple tools provide a scalable and effective solution for Airbnb and hotel industry in analytics. Thank you.
Okay, thank you.